All right, last time we left off having talked about the first kind of figure numbers, and we talked about triangular numbers. Is that not correct? Excellent. So got the right class with the right notes. Always a good sign. And we had created these triangular shapes, and we counted the number of dots, if you will, that it took to make the shape, and we noticed some interesting patterns among the number of dots. Their patterns were not arithmetic, but the first differences was the difference between each successive term actually was arithmetic. And the next set of figure numbers that we're going to take a look at are square numbers. And square numbers look very similar, but they're going to be in a square shape. The first one has just one dot. Okay. Oh, I didn't mean to do that. The next one would have four dots in the shape of a square, so they kind of look like the four corners of a square. And the next thing that happens is that instead of like it was with the triangle, I actually am building both the width and the height at the same time, not just adding an additional row at the bottom. That's kind of what it looks like with the triangle shape. You just added this extra row on the bottom. Here, it's almost like you're adding the row on the bottom or top, however your perspective is, and on the side. Because you have to keep the shape squared. If I only added the row on the bottom, then it wouldn't be a square number. It would be a rectangular shape. It would be a rectangular number. So I have 9 dots here. The next one has 4 dots across on the bottom, and it's 4 dots high, giving me a total of how many dots? 16. And you should look at those numbers, 1, 4, 9, 16, and besides the picture that they're creating, say, yes, those are the squares, right? These are the numbers you get when you square each individual number. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. Okay. So both visually and in terms of what we understand algebraically, these are square numbers. All right, let's take a look at an interesting problem. This actually really happened. Last fall, I don't know if you guys are aware of this part or not, but there were different colleges created across campus. We changed kind of the structure of how the campus was created. And there were formed 6 separate colleges. And the College of Arts and Sciences kind of split, and so you guys are actually in a different college than I am in now. So I'm in the College of Science and Mathematics, and the Education Department in Science is in the College of Arts and Humanities title. And anyway, so our newly formed Hurley College of Science and Math had a meeting. On the board, the value 3.1415, and then there were some dots after it was placed, and we were asked to find the next terms of the sequence of numbers. So I want you to write down, without talking to your neighbor, what would you say are the next 2 numbers in this sequence? Okay? So write down your guess as to what it would be. What would you put next? Everybody has to write down some guess before I'm going to move on. Everybody have a guess? Okay. What would you guys put as your next 2 numbers? Somebody tell me. 1, 6. Did everybody put 1, 6? Anybody think differently when you saw that problem? Because when I went into the room, I didn't put 1, 6. I came in, and this is what I did. The next numbers, just to make sure we're down right. Those are the next numbers I put when I saw this number. What do you know why? Yeah, that's an approximation for pi. So when I saw 3.1415, I said, well, I do. What else could it be? Just like you guys said 1, 6, what else could it be? Why is she making a big deal about this? So I bring this up as an example because I want you to realize that you generalized and I generalized something. We generalized it differently based on our prior knowledge and how we looked at that and thought about it, right? I thought about it and it hit home because this is a number I've seen and I've used some decimal representation of this before, and I said, well, let's do that. And you looked at it and you looked at it from a very pattern kind of viewpoint, probably partly because of what we're working with, right? But there's different ways of doing this. This idea we talked about, of making inductive versus deductive reasoning, right? This idea of taking a pattern and making a generalization. It doesn't always lead us down the right path. So there are two very valid, different ways of interpreting what two numbers should come next. Okay, just a moment.